Hi, my name is Todd Lamley, and welcome to Module 12, Wireless Technologies. This is 12 out of 14 modules in this CCNA series, so I hope you've held with us the whole time, kept up your study and your intensity level, because you have to have a pretty good intensity to get through the CCNA objectives. And a lot of fortitude. Did I mention that one? Anyways, if you've come this far and you've started at the beginning, and you're using this as supplemental material, which means you're reading a book on the other side, hopefully my book, but any other book would work as well, I suppose. And you've only got this module and a couple others to go, so there's no reason to quit now. Now, the CCNA objectives for wireless are pretty clear. They're very introductory, which means that they're not that hard, but there is some basic foundational material you'll have to know. So in this section, in this module, I'm going to show you the CCNA objectives for wireless technologies. So what are the differences between a wireless LAN and a LAN? Well, when we talk about a LAN, think about Ethernet. And this is a bounded media where wireless LANs are unbounded media, means that radio waves are propagated through the air at the physical layer. Wireless LANs use CSMA-CA, collision avoidance, instead of CSMA-CD, collision detection, that the Ethernet LANs use. Now, this is half duplex. Wireless is half duplex. Sure, there are some new wireless networks that run full duplex, but they're not out there too much in the non-commercial market. There are some in the commercial market, but they're very expensive for now. And we'll talk about them later in this module. Just remember for now that just because you go to a basic wireless network does not make your network better than if you just had a hub network. Radio waves have problems that are not found on wires, and these are connectivity issues, which give us coverage problems, which means we're not going to be able to cover maybe our whole building. We have interference and noise issues, which means it's going to make our network drop or make it not work at all, actually. And of course, we have privacy issues or security issues. As everyone knows, having a wireless network is like putting an RJ45 jack out into the parking lot. So you got to be very careful with your wireless networks that even if you have security on them, that you don't let your wireless signals propagate out past your walls of wherever you're at, your building, your home, etc. Access points are shared devices similar to Ethernet in an Ethernet hub, which means only one device can communicate at a time, and it can only transmit and or receive at the same time, not both. So this is a problem with wireless networks, although this does not mean we should take our wireless out and say we need to put wired in because they're better networks. Certainly they are, but that doesn't mean anything. I want wireless networks. If I check into a hotel and they don't have a wireless network, I'll check out of that hotel and go to the next one because I know they do, and I want my wireless networks. Just because it's not a better network does not mean we're not going to use it. Now also remember that wireless LANs are country by country regulations. The United States has regulations that other countries won't have. So if you're communicating on your wireless network in America, does not mean you can travel over to another country and your wireless network will keep working. Different cards will work than others, but just don't take that for granted. So radio frequency transmissions is what we use. These frequencies, radio frequencies, are radiated into the air via an antenna, creating radio waves. Objects can affect radio wave propagation, resulting in reflection, scattering, and absorption. So reflection meaning what? That maybe it'll hit some water and reflect off the water, or hit a wall and reflect off that wall. Scattering is what we'll see when we hit a lake of water, where the signal will hit the lake and the signal will go in all directions. And then absorption, we have like pine needles of trees love to absorb 2.4 gigahertz ranges, which is our most popular frequency. Now higher frequencies, say in the 5 gigahertz range, allow higher data rates, however a shorter range. So as we'll see in this module, we have 3 open frequencies or unlicensed frequency ranges. That's the 900 megahertz range, the 2.4 gigahertz range, and the 5 gigahertz range. Certainly they're going to open up more frequency ranges to the public, but right now they are not. 900 megahertz goes a long distance, but with very, very little data. Great for something like, I don't know, garage door openers. That's a great example. The 2.4 gigahertz range works, and it works well. So it goes a good amount of distance, 100 feet, 100 yards, something like that, up to 100 yards, maybe depending on your location in your building and the objects in there. And the 5 gigahertz has the highest bandwidth, but it has the shortest distance. Now, organizations that define wireless LANs, the ones that we care about here are the IEEE, which define our data link and physical layers, and then of course there's something called the Wi-Fi Alliance. This is a Wi-Fi alliances based a company out of San Jose. It's a non-profit supposedly, I guess. Anyways, what they do is you make a 802.11 or IEEE specification product, and you say, hey, I've made a product, and it's supposed to work with the IEEE specification, so here it is. You give them $20,000, and they test your products to make sure that it meets the regulations of the IEEE. If so, they're going to stamp it with this little thing down here in the right-hand corner, Wi-Fi certified. If you look on the bottom of your cards, or if you have any external cards or access points, you should see this little stamp here. Now here's the three frequency ranges that I've already mentioned. We've got the 900 megahertz range, the 2.4 gigahertz range, and the 5 gigahertz range. They're certainly talking about opening up the 3.6 gigahertz range, and there's another range in here called the 4.9 gigahertz range. That is open, but it's a licensed frequency, but it's used for public services like police, fire, and ambulances. So we can't use this and go down to Fry's and buy the 4.9 gigahertz range. But we should be able to get something in the 3.6 gigahertz range in the next couple of years. Now, the 900 and 2.4 gigahertz range are called ISM, which means Industrial, Scientific, and Medical Frequency Bands, ISM. No license required, which means that anybody can make product for it. Now, there is no exclusive use. Everyone is capable of using this. That means if you can get a product for it, your neighbor can get a product for it. So if they're blasting out their signal, then they can override what you're doing. This is the difference between a wired and wireless, isn't it? And I think we've seen this a lot. You bring up your access point and you might see, or your wireless client, and you might see 10, 20 access points, maybe even more. Even where I am out in the sticks, out in the country right now, I can already see a bunch of access points around me, not knowing even where they're coming from. But anyways, remember that you have to be careful about your wireless signal, because if you can see it, someone else can probably see it. So be careful with your access points. Now, remember that in the wireless, it's no exclusive effort, and interference is definitely possible. Since everyone has a 2.4 gigahertz access point, I'm sure most of you already have a 2.4 gigahertz Linksys at home or Netgear or something like that. And then at work, of course, we're going to have them, and everyone loves to work in the 2.4 gigahertz range. Why? Because it's very inexpensive, and all our laptops that ship come with it now. We also get 5 gigahertz cards in all our laptops as well, but the access points seem to cost a little bit more money, a little bit more to configure, and so on. The 2.4s just kind of configure themselves if you turn them on. Okay, so we need to be aware of the different frequencies, and what we're going to talk about in this module is the power that is output from each one of those, and you need to know how to change those.